So again, this is basically has a hydrogen, so I can give away this hydrogen. So this will be the acid and this will be the base. If there is an acid, always another molecule has to react as a base. So this is the acid, this is the base. And for those, we need to determine which one is the conjugate acid, which one is the conjugate base. Again, you can do it either way. So you can do it as you look here, who has most of the hydrogen, and then this will be the conjugate acid and this will be the conjugate base. Or you basically can do it in another way. So it's NH3 plus, right? HNO3, NH3. HNO3, NH3, give away NH4 plus NO3 plus minus. So you can, again, we have an H here, so we'll consider this an acid. And if this is an acid, then this is a base. And then the first method is to look here and see which one has potential hydrogen to give. And the donating hydrogen is a characteristic of an acid. So this will be conjugate acid. And this will be conjugate base. Another method to do this is to ionize this as H and NO3. NO3. Okay. So the hydrogen will travel or will be received or donated to the NH4. The left will be the base. So the left of the acid will be the conjugate base. So you can do it either way. The first method is to determine which ones have potential to give hydrogen. So this one is acid because it has hydrogen at the beginning. So this one is base. And then in here, to determine the conjugate acid, you need to actually find which one has more hydrogen to give away, which is this one. And then we do have conjugate acid, and the other one will be the conjugate base. So you can see here that this and that will be acid and conjugate base pair. So this is the first pair. Base and conjugate acid is NH4. This is the amphoteric substance that we talked about. The example is like water. It reacts as a base and as an acid depending on the solution that the water has. How to name acids and bases. So for naming acid and bases, we'll start with naming the base because the base is very easy. So basically anything that, as we said before, anything that will have the hydroxy group at the end in the formula, then it will be base. So all of these are bases. And then you call the first ion, as usual, sodium. And the second polyatomic molecule is the hydroxide group. So sodium hydroxide, potassium hydroxide, barium hydroxide, aluminum hydroxide, and so on. So there is no tricks in calling any bases. The only thing is to figure out it's a base by finding the OH. Here, with the acid, we have two situations here. If it's just acid and if the formula has acid, So naming acid um, with ion or with polyatomic molecule. Okay. With an ion, it's like HCl, H2SO4. No, HCl, HF. With polyatomic molecule, it's like H2SO4. This is an example, H3PO4, HClO4, O3. So here, this is acid with a hydrogen, like HCl. So basically what you do is, the name of the HCl is hydrochloric acid. So you basically use hydro at the beginning, and then the first part of the chloride ion, and you delete the rest and you add IC acid, hydrochloric acid. For the polyatomic ion, it depends. So if the polyatomic ion is called, has the ATE letters at the end, like this one, chlorate, so the acid will be chloric acid. So you turn the A to ic and add acid. Here, if you do have ITE at the end of the polyatomic ion, like here, chlorite, which means it's missing one oxygen from the chlorate, which has the full number of oxygen. So chlorite, the acid in this case will be chlorous acid. So you add OUS to the end of the positive ion. So that's it. So this is how to name the acid. Let's practice. See here, HBr. So HCl, hydrochloric acid. Try to call HBr. Br is bromide. So hydrobromic acid. HI, iodide. Hydroiodic acid. HCN, cyanide. Hydrocyanic acid. The polyatomic groups are here. So NO3, you can look here. NO3 is nitrate. So you can say that this is a nitric acid. Nitrite was missing one oxygen. Nitrous acid for this one. SO4, sulfate, sulfuric acid. Sulfite, missing one oxygen. Sulfurous acid. Acetate, acetic acid. And this is the vinegar, by the way. And this is the formula of the vinegar. Phosphate, phosphoric acid. When it turns the phosphate into phosphite with losing one oxygen, will be phosphorus acid. Chlorate, when you have all three oxygen, chloric acid. When you have chlorite, missing one oxygen, chlorous acid. So this is naming the acids. Select the correct name of each of the following. Try to solve it. Pause the video here and try to solve it, and then turn on the video again. HBr, we have the bromide ion, so, and it's H, so hydrobromic acid. It cannot be bromic acid, bromous acid. It's hydrobromic acid. H2CO3 is, so CO3 is carbonate. So this acid will be carbonic acid, because carbonate, ATE, carbonic acid. BrO2 is It's a polyatomic molecule called bromide. So it will be bromous acid. Bromous acid. Again, match the formulas of acid and bases with their names. So bases are easy, so let's do C and E so we can cross them out. Sodium hydroxide. So where are the hydroxide? We only have number 2 and number 5 are the only ones that have possibilities to be bases because they have the OHs. So sodium hydroxide is this one. Calcium hydroxide will be this one. Okay. And then HNO2, number 1, would be NO2 is nitrite. So it turn into OUS, so nitrous acid. H2SO4, SO4 sulfate, ATE, so sulfuric acid. HiO3, iodate, so it will be ATE, so be iodic acid. In each of the following equation, did we do this? No. Identify the pronounced Lowry acid and base in the reaction. Yeah, we did this. Okay, and we did that. And we practiced on this. The pH scale or the pH. pH means measuring the potential hydrogen ion concentration in a solution. Potential hydrogen ion concentration in the solution. We can measure the pH using in 3 methods. We can use pH meter. It's a machine. You will put the electrode in the solution and you stir it and you just get your readings. Or the pH paper, as you can see, it's just a paper that turns into colors, and the colors, depending on the pH, you have a code here that you compare it, and each code has numbers, as you can see, and you can know the pH number by comparing visually the colors. Or by pH indicators, chemicals that you add in the solution, and basically it turns to different colors. Whenever it turns to specific colors, then you can say that this is an acid, this is a base, or this is neutral. We'll see how in the next few slides. So the pH, these are some of the pH scale, some of the kitchen stuff and everyday stuff and their acidity, like to determine if it's acid or base, depending on the number they will get or how much hydrogen ion in their solution. So you can see that here acids, all the reds are acids, 7 is neutral, and all the blue are basic. Acids, you can see soda, orange, meat, milk and cheeses, and also bread. All of these are considered acids. Neutral is the water, some of the dairy products as well. Bases are all the cleaning stuff will be bases, like basic, like bleaches and ammonium and any cleaning stuff. Usually it's bases. So and if you look at the numbers here, I can make it bigger here. So if you look at the numbers here, you can see that the numbers start from 0 all the way to 13 with the neutral around the 7 in the middle. So this is what we call the pH scale. These numbers represent an easy way to